College 1A. What's up? So if you didn't do this already and saw in the beginning of the video, don't forget we're going to talk about a deck of cards today. So if you're not familiar with a deck of cards, go to Google, type in deck of cards sample space, pull up a Google image for that. That'll show you the deck of cards. There's 52 cards in a deck. There's 4 suits. There are clubs, spades, hearts, and diamonds. So we're going to reference that just because it fits well with what we're going to talk about today. So today we're going to talk about mutual exclusivity, which sounds cool, doesn't it? All it is whether 2 events can happen at the same time. Now, it gets slightly confusing for some kids because when you talk about things being mutually exclusive, that means that they cannot happen at the same time. They cannot happen at the same time. So when things are mutually exclusive, they cannot happen at the same time. So when you say things are not mutually exclusive, that means that they can happen at the same time. So the real first thing we've got to get our heads around is knowing that when things are mutually exclusive, they cannot happen at the same time. And when they are not mutually exclusive, they can happen at the same time. So that's the first obstacle we got to get over. And when we're referencing these ideas and I say things are mutually exclusive, because there's no negative in that sentence, it gets a little confusing. So when I say they are mutually exclusive, they cannot happen at the same time. When I say they are not mutually exclusive, they can happen at the same time. I've said that a bunch of times because I've seen a lot when kids struggle with this. So keep that in mind. You might want to write that down somewhere so that you can reference it as the video goes on. So what are we going to do with this, Goodman? Well, real simple. When you're talking about probability, sometimes you don't want the probability of just one thing. You might say, hey, I want the probability of this or this. And that's where a deck of cards comes into play. So we're going to talk about the probability of A or B. So the probability of A or B happening. So now I don't mind which one it is. I want to know what's the probability of me getting either one. Well, the key here is, well, can they happen at the same time? Why does that make a big deal? Well, we don't want to find the probability of A and the probability of B and just put them together because they may overlap and we may get a faulty probability. So what we've got to do is understand whether events are mutually exclusive or not mutually exclusive. So let's start with events that are mutually exclusive. Now, remember, when we're talking about mutually exclusive, that means they cannot happen at the same time. So if I have 2 events, probability of A or B, and they are mutually exclusive, they cannot happen at the same time. That simply means that the probability of A or B is the probability of A plus the probability of B. So if I want either or, I just find the probability of each, add it together. Done. Now, what if they are not mutually exclusive? They are not mutually exclusive. And again, if they are not mutually exclusive, that means they can happen at the same time. So again, a little bit backwards, right? Well, this time we've got to account for if they're not mutually exclusive. That means I can get both options at once. So I have to account for that. So this time I'm going to do my probability of A. I'm going to add to that my probability of B, and then I have to subtract the probability of A and B. Sorry, I squeezed it in there at the end. My board's only so big here. So that accounts for that overlap. So not mutually exclusive means they can happen at the same time. They have overlap. So that's why we have to subtract when they happen together. Okay? So what I would probably do at this moment is I would pause the video. I would write these things down so that you can reference it. So you have the definition of mutually exclusive. You also have the formulas for when they are mutually exclusive and when they are not mutually exclusive. Beautiful part about statistics and probability is just wading through what they're asking, what you have and applying the appropriate formula. So go ahead, pause the video, write that down with your definitions. We'll do some examples. Okay, so let's go ahead and do some examples. Now, the first thing is when we're looking at this, we're talking about a deck of cards. So we're going to say, what's the probability of me reaching into that deck of cards and getting a jack or a 4? So since I'm doing that or probability, this or that, I have to decide, is this mutually exclusive? Can I get a jack and a 4 at the same time? Well, the answer to that is no, I can't. I can't get a jack that's a 4. It's either a jack or a 4. So that means that these guys are indeed mutually exclusive. Okay? Again, there's that whole thing. It cannot happen at the same time. Therefore, they are mutually exclusive. So careful there. So my probability for mutual exclusivity is probability of A or B equals probability of A plus the probability of B. Okay, so real simple, the probability of a jack or a 4 says find the probability of a jack, add to that the probability of the 4. So if you need to go back to your sample space of the deck of cards, go ahead. So if I look at my deck of cards and I say, okay, what's the probability of me getting a jack? Well, there are 4 jacks, there are 52 cards. So we'll put that as 4 over 52. We're going to add to that the probability of me getting a 4. Well, again, if I look at the deck of cards, how many 4s are in there? Well, there's 4 4s. There's 1 in each suit. So that is also 4 over 52. So all I have to do is go ahead and add those two probabilities together. And I'm going to go ahead and erase this so I have room. Again, if you have your calculator, use it. If you do not, go to Desmos. We also could reduce those very easy and come up with our probability. I know you guys love to use your calculators. So if I add those together, I'm looking at a probability of 2 out of 13. So my probability of getting a jack or a 4 is 2 out of 13. So now let's talk about going to our deck of cards, excuse me, and getting a heart or an ace. So again, since this is an or probability, I want this or that, I have to decide, is it mutually exclusive or not? So if I look at my sample space of a deck of cards, can I get a heart and an ace at the same time? The answer to that is yes, I can. So that means since they can happen at the same time, they are not mutually exclusive. I'm going to abbreviate that as ME just to save time. They are not mutually exclusive. That means the formula that I am facing is a probability of A or B would be the probability of A plus the probability of B minus the probability of A and B. So now instead of finding just the probability of each and adding together, I have to account that overlap since they can occur at the same time and subtract that. So I'm going to come down here so that I have room. So we're doing probability of heart or ace. So start with the probability of a heart. So if I look at the hearts, and I'm talking about any card that has a heart on it, that's that whole suit of hearts, which means it's 13 out of 52. But I think we can look at that and go, well, that's a quarter of the deck. Each suit is 1/4 of the deck, or a quarter. So I'm going to write that down as 1/4. Then I go to my probability of B, which in this case is probability of an ace. Well, my probability of an ace, there's 4 aces in the whole deck, and there's 52 cards total. We could also reduce that to 1/13 if you want. I don't think that one's as obvious, so I'm going to leave it as this. And of course, if you put this as 13 over 52, your calculator will, of course, calculate that. Now, the difference between this problem and before, since this is not mutually exclusive, in other words, they can happen at the same time, I have to take into account that overlap. So the probability of A and B is, okay, what's the probability of a heart and ace? Well, if I look at my deck of cards and focus in on the hearts, there's only 1 ace that is a heart. So that means there is 1 out of 52 total cards that is an ace and a heart. Remember, we're taking 1 card out of the entire deck. So my sample space, my total amount or total events in there is always going to be 52. So let's go ahead, turn to our calculator or Desmos, and let's go ahead and add this up. So I'm looking at 1/4 plus, whoops, I typed in 4 or 5 out of 52. 4 out of 52 minus 1 out of 52. So if I punch that in, I'm looking at 4/13 for a total probability. 4/13, which isn't really bad, but again, keep in mind, we were talking about a heart, which is any of this one suit, and then we added some aces onto that. Another way to think of this that students like to think of it is they do the probability of A, which is the hearts, and that's 1/4. And then when they go to the probability of B, they already account for taking that heart out that is also an ace. I recommend not doing that because that leads to some struggles. Okay? So at this point, what we're going to do is we're going to put some examples on the board. We're going to have you pause the video, try them, come back and check your solution, see how we're doing. All right, guys, let's have you try this one. So we're going to do probability of a heart or an even number card. So a heart would be any card in that deck that is of the suit of hearts. Probability of an even number card would be any card that has an even number on it, which of course is 2, 4, 6, 8, and 10. There are no other numbers in there. So the first thing you have to decide is this mutually exclusive or not? Can it occur at the same time? If it can occur at the same time, it is not mutually exclusive. If it can't, then it is mutually exclusive. So make that decision, choose the correct formula, go ahead, pause the video, give it a try. All right, welcome back. So, probability of heart or an even card. So, can these occur at the same time? The answer is yes, they can occur at the same time, which means it is not mutually exclusive. Which also means our formula now for probability of A or B is the probability of A plus probability of B minus the probability of both occurring at the same time. We've got to account for that overlap since they are not mutually exclusive. So, probability of A in this case is probability of a heart, and of course I went straight to 1/4. You could do 13 out of 52, but I think it's very obvious that a suit is 1/4 of the whole deck. Now we go to probability of B, which is the probability of an even number card. Well, the easy way to figure this out, you can look at your sample space and count it all up, or you can say, okay, there's a 2, 4, 6, 8, and 10. That means there's 5 evens in each suit. Since there's 4 suits, that means there's 20 even numbered cards. So we have 20 over 52. Then we're going to subtract to that the probability of A and B occurring at the same time. That means a heart that is even. And of course, since we just said there's a 2, 4, 6, 8, and 10 of each suit, that means there are 5 numbers that are indeed hearts. So that's why this is 5 out of 52. So then you turn to your calculator, Desmos, throw that sucker in there, and of course it does give you a calculation of 7/13, which is slightly over half. You have over 50% chance of getting a heart or an even card. Hopefully you got that. Let's try another. Okay, your next example. I would like you to find the probability of whether you would get a face card or a diamond. Now, first thing that I remember from doing this stuff in class a lot, face card, any card that has a face on it. If you look at the deck of cards, the only cards that have a face on it are the Jack, Queen, and King. Aces are not face cards. I know it's a high card and it's at the end of the deck, but it is not a face card, does not have a face on it. So this is just Jack, Queens, and Kings. Or a diamond, which is the other red suit. We focused on hearts, we're going to do diamonds this time just to mix it up. So go ahead, pause the video, give this one a whirl, and then we'll come back and check our answers. All right, guys, welcome back. So our first determination is whether it's mutually exclusive or not. It is not mutually exclusive. We can get a face card that is a diamond. They can occur at the same time. They are not mutually exclusive. So probability of A or B becomes probability of A plus probability of B minus probability of both occurring. So probability of face card or diamond. There are 12 out of 52 face cards. There's Jack, Queen, King. There's 3 in each suit. Times 4, of course, is 12 total face cards in the deck. 12 out of 52. Plus the probability of a diamond, well, there's a quarter. A quarter of the deck is each suit. You could also have 13 out of 52, but again, I think that's pretty easy to get to. Minus probability of face card and diamond. Well, like we said, Jack, Queen, King in each suit. So there are 3 face cards in the suit of diamonds. So that's why we've subtracted 3 out of 52. So if you throw that in your calculator or Desmos and reduce, you will get 11/26. Next example, let's have you find the probability of getting an ace or a 10. So go ahead, pause the video, give it a whirl. All right, guys, welcome back. So first determination is when we're dealing with an probability, is it mutually exclusive? In this case, an ace or a 10 is mutually exclusive. You can't get an ace that is also a 10. Just can't happen. So we're going to focus in on our formula. Probability of A or B is just probability of A plus probability of B. Since they cannot happen at the same time, we don't have to take out when they do. So probability of an ace or a 10. Nice thing is they're the same probability. There are 4 aces in the deck, so it's 4 out of 52 for the aces. Likewise, there's 4 10s in the deck, so that's also 4 out of 52. So when we add those together, we will get 8 out of 52, which does indeed reduce to 2/13. And that's it. So hopefully that was pretty easy. All you have to do is determine whether it's mutually exclusive or not and apply the correct formula. Keep in mind, mutually exclusive cannot happen at the same time. Not mutually exclusive can happen at the same time. So keep those notes close by. You have a Google form, 3 questions. You can have your notes in front of you. Go ahead and complete that. We also have a Google Meet today. So if you have any questions, problems, concerns, we can even talk about the questions on the Google form to make sure that we're okay with this. Hope everybody's safe, happy, well, and as always, don't forget, wash your hands, help around the house. See you guys.